On the evening of August the 1st, a prefecture bulletin in southwestern France used a single word that firefighters had been waiting 10 days to hear: fixed. The Gironde megafire, the one that emptied entire coastal towns and pushed smoke across Bordeaux, was finally pinned in place. 42,000 hectares of pine forest and dune belt gone. A burning edge 240 kilometers long, which is roughly the drive from Bordeaux to Toulouse, except every meter of it was on fire. More than 220,000 people evacuated from the Gironde alone, a number close to the entire population of the city of Bordeaux walking out of its own front door. 252 buildings destroyed, more than 330 firefighters injured. And then, less than 48 hours later, Météo-France began coloring its map orange again. Not for heat this time. That is the story here, and it's stranger and more dangerous than the headline version. Europe's heat is breaking. The dome that has sat over Iberia and France for weeks, the one that dried the fuel for the largest wildfire France has seen since 1949, is collapsing right now. Everyone wants to treat that as good news. Forecasters are treating it as the beginning of the second act. If you want to understand what is about to happen to a continent that has spent 6 weeks being cooked, stay with me through the next few minutes, because there's a piece of atmospheric physics in this that almost nobody explains on the news, and it changes how you read every summer from here on. Subscribe if you want the version of these events that tells you what's confirmed and what isn't. Here's what is measured right now, this week. On August the 3rd, Spain's National Weather Agency declared the 4th heat wave of the summer officially over. Not eased, over. Cooler Atlantic air pushed in from the north, and maximum temperatures across most of the peninsula dropped back toward the low 30s in Celsius, which is somewhere in the high 80s and low 90s if you think in Fahrenheit. Normal for early August. But on the very same bulletin, the very same agency raised orange warnings for storms and heavy rain across Aragon and Catalonia, with hail flagged for the lower Ebro, Huesca, and Lleida. In France, the picture was even louder. On August the 3rd, around 10 departments went to orange vigilance for thunderstorms, while 20 were still on orange for heat, which tells you the two things were happening at the same time in the same country. Ariège, Tarn, Tarnet-Garonne, Haute-Garonne, then Corrèze, Dordogne, and Lot carried theirs into the following day. 96 departments were placed under yellow storm vigilance, and it's worth knowing that 96 happens to be the total number of departments in mainland France, Corsica included. La Chaîne Météo flagged the hail risk as particularly high in a band running from Occitanie through parts of Aquitaine and the Auvergne, up through Burgundy, all the way to Alsace, with stones forecast to reach 5 centimeters across. 5 centimeters of ice doesn't sound like much until you do the arithmetic on how it arrives. A hailstone that size falls at something close to 100 kilometers an hour. So picture a plum thrown at your windscreen at motorway speed, and then picture several thousand of them in 90 seconds. That's what a heat dome collapse looks like at ground level. So why does it work this way? Why doesn't the heat just quietly stop? Because a heat dome is not a temperature, it's a structure. What sat over Western Europe through late July was a high-pressure ridge locked into a pattern forecasters call an omega block, named for the shape it draws on a pressure chart, a big dome in the middle with a deep low on each side, one anchored over the North Atlantic and one out east over Russia. The two lows act like doorstops. The high in the middle can't move, so it sits and it sinks. Sinking air warms as it compresses. It also suppresses cloud, which lets the sun work on the ground uninterrupted, day after day. The ground heats the air above it. That air can't escape upward because the ridge is pressing down on it like a lid, and so the whole column gets hotter and drier and more loaded with potential every single day. That's the part people miss. The dome isn't storing heat, it's storing energy. And heat is only one of the forms that energy can take. Meteorologists measure the convective part of it in joules per kilogram, and under and around these ridges, those values climb into ranges you'd normally associate with the American Great Plains in spring, rather than with the French countryside in summer. 2,000 3,000 joules per kilogram over the Mediterranean basin during the late July episode. All of that is potential. It sits there because the lid is on. Now take the lid off. When the blocking pattern finally breaks down, and it always does, a trough of cooler air slides in from the Atlantic and undercuts the ridge. The lid doesn't lift gently. It gets shoved aside, and the boundary between the cool air arriving and the hot air leaving becomes the most violent piece of real estate on the continent. All that stored energy converts in hours. The air that couldn't rise now rises very fast indeed, and it carries an enormous load of moisture with it. And what comes down is hail, downbursts, lightning, and rainfall rates that no drainage system in southern Europe was designed for. This is the sentence worth carrying out of this video. The stronger and longer the heat, the more violent the ending. The dome doesn't get switched off, it gets cashed in. There's a second number from this summer that decides how bad the cashing in gets, and it has nothing to do with the sky. It's about the ground. Spain's meteorological agency confirmed that July of this year tied the record set in 2022 as the warmest July the country has recorded. That's the part that made headlines. The part that didn't was the second half of the same finding. July was also the driest month in Spain since national statistics began in 1961. Not the driest July, the driest month of any name in 65 years of record keeping. I've read a lot of these bulletins, and that one stopped me. Because a dry month and a record dry month behave completely differently when the rain finally comes. Here's why. Soil absorbs water at a rate, not a volume. Healthy soil with moisture already in it, with roots running through it and a layer of organic material on top, behaves like a sponge that's already slightly damp. It takes water in. Soil that has been baked for 6 weeks under a ridge with no cloud cover does something counterintuitive. It develops a crust. The surface hardens and its ability to take in water at speed collapses. So when a storm drops 30 or 40 millimeters in half an hour onto ground that was begging for rain a week ago, most of that water never enters the soil at all. It sheets, it finds the nearest low line, and it moves. And the sequence that produced this summer makes it worse, not better. Researchers with World Weather Attribution published an analysis at the end of July looking at exactly this, and the chain they describe is almost cruel in its neatness. January of this year was the wettest January Spain had seen in a quarter of a century. Wet winters grow vegetation. Grass, scrub, undergrowth, all of it flourished. Then came a spring and summer that were anomalously hot and dry, which stripped the moisture back out of that vegetation and out of the soil beneath it. So the wet winter built the fuel and the hot summer cured it. That same team found that fire weather conditions as extreme as those seen in central Spain this July are now at least 20 times more likely than they would have been in a pre-industrial climate, and that in southwest France the increase is at least a factor of 2, which they describe as a conservative estimate. Quick question before the next part, and I'm curious about this one. Have you ever been outside when a summer storm finally arrived after weeks of heat? That moment when the temperature drops 10 degrees in 2 minutes and the light goes green? Tell me where you were. I read these. Now, the hazards, in the order forecasters actually rank them, because the order is not the order the news uses. Hail comes first, and it's first because it does the most economic damage in the least time. The corridor identified for this pattern change runs from France and the Alps through Germany, Czechia, Austria, Poland, and Slovakia, and down toward the Balkans, Romania, and Ukraine. That corridor exists because the strongest storms don't form under the center of a heat dome. They form around its edges, where the hot air meets something that isn't hot. Under the dome, the sinking air actively prevents storms. At the rim, it's the opposite. The European Storm Forecasting Group Estifex had already issued elevated risk levels across parts of Poland and the Baltic states at the start of the month for large hail, damaging gusts, heavy rain, and a risk of a few longer-track tornado events alongside a separate risk zone for eastern Spain. Second, damaging wind, not the wind you feel walking to the shops. When a storm's downdraught hits the ground and spreads outward, gusts above 100 kilometers an hour are routine in these setups, And in the Central European storms that followed last year's heat, those gusts took roofs off buildings in Slovakia and killed a woman near Milan when a tree came down. Wind is also the hazard that makes the first hours of a pattern change dangerous for the fire crews, because a storm arriving at a fire line does not arrive as rain. It arrives as a wind shift, and it arrives before the water does. Third, lightning onto ground that is still the driest it's been in 6 decades. Dry thunderstorms are the ones that ignite rather than extinguish. And there's an unsettling detail from the Gironde fire that shows how tangled this gets. That fire grew so intense it built its own storm cloud above itself, a pyrocumulonimbus, and that cloud produced its own lightning, and that lightning started new fires, a fire that was making its own weather. Météo-France kept fire danger at high to very high across the south, southwest, west, the Mediterranean coast, and Corsica right up until the wetter pattern arrived. And fourth, the one that gets almost no coverage at all, and the reason I wanted to make this video. This summer, France and Spain have effectively installed an enormous amount of new roofing. Think about what a forest floor does. Leaf litter, needles, roots, soil structure, all of it working as a slow surface. Rain hits it, gets held, gets released downhill over hours or days. Now burn it hot enough and two things happen at once. The absorbent layer is gone, and the mineral soil underneath gets baked to the point where it repels water instead of accepting it. Meteorologists describe the result as hydrophobic. Rain lands and runs off it the way rain runs off a tiled roof. And roofs don't just fail to absorb, they direct. They take everything that falls across a wide area and deliver it concentrated to a single low point. France has burned about 115,000 hectares this year, a national record set before the traditional peak of the fire season even arrived. That's around 1,150 square kilometers, close to 3/4 the size of Greater London. Spain's figures for the year run from about 130,000 hectares upward, depending on which agency you follow, with roughly 140,000 burned in the second half of July alone. The fire near Avila reached about 44,000 hectares, which the Spanish Interior Minister described as the largest and most destructive fire in the country's history. The La Mirla fires in Guadalajara took another 35,000. Every hectare of that is now roofing, and the thunderstorms are arriving over it in the same fortnight. American forecasters have quantified how little rain it takes. On a severely burned slope, half an inch in under an hour, which is around 13 millimeters, can be enough to start a flash flood. In the most intensely burned ground, 1/4 of an inch will do it. A National Weather Service meteorologist in Colorado put it about as bluntly as a scientist can when a burn scar was facing storms in late July. Rain over a burn scar, he said, is a double-edged sword. The good news is it helps put the fire out. The bad news is horrific flash flooding. He also noted the threat doesn't end with the fire season. It lasts years until the vegetation grows back. Here's the part I promised you, and it's the reason this particular week matters more than a normal pattern change. Look at where Spain's storm warnings were raised. Aragon, Catalonia, the Lower, Ebro, Huesca, Lleida. That is the Ebro Basin, the largest river system in Spain, and it is precisely the basin where a study published in Natural Hazards and Earth System Sciences examined what happens when you stop treating wildfire and flood as separate problems. The finding is straightforward, and it's been sitting in the literature since 2024. Burned catchments change how the whole basin responds to rain. Runoff increases, flood risk downstream amplifies, and yet fire is routinely left out of flood risk assessment altogether, treated as a different department's problem. So this week, on that basin, you have severe storm warnings, hail forecasts, and a country that just recorded its driest month since 1961, with fresh burn scars scattered across the interior. Forecasters in Spain have flagged that the instability builds further from around August the 10th, with the northeast quadrant identified as the focus, and with conditions becoming favorable for the cutoff low systems the Spanish call a DANA. And there's a fuel supply sitting underneath all of it that has nothing to do with the land. The Mediterranean has been running through one of the most significant marine heat anomalies observed anywhere on the planet this year. Copernicus recorded the first half of this year as the third warmest on record for the Mediterranean, behind only the 2 years immediately preceding it. On the 29th of June, satellite data showed anomalies of around 6 degrees Celsius above the long-term average in the western Mediterranean, with the Gulf of Lion off southern France and the Ligurian and Tyrrhenian seas along Italy's west coast among the hottest patches. A warm sea doesn't create storms. What it does is load the atmosphere above it with water vapor, and water vapor is the fuel. As one Spanish meteorologist framed it, a warm sea doesn't produce more cut-off lows, but it makes the ones that do arrive unload far more intensely. The same system that in a cooler year drops a heavy shower can over exceptionally warm water produce torrential rain and hail and totals that arrive in a few hours. Now, here's where I have to be straight with you, because this is exactly the point where a lot of channels would tell you something they can't possibly know. Nobody has forecast a disaster for Europe over the next 10 days. What forecasters have done is describe a pattern with elevated potential over a corridor, across a window. That's a different statement, and the difference matters. Everything I've described is normal August physics. Heat domes always end. They always end in storms, because that's the only mechanism available to end them. A continent going from 40 degrees Celsius to hail and thunder inside 72 hours is not evidence that something has gone wrong with the planet's machinery. It's evidence that the machinery is working the way it has always worked. Most of the storms that develop this week across France, Spain, and Central Europe will be ordinary summer thunderstorms. Loud, brief, locally unpleasant, and then over. That's the base rate, and it should be the default expectation. What has changed is not the physics. It's the state of the ground the physics is landing on and the amount of moisture the sea is handing to it. Those two things are measurable, they're documented, and they're what shifts the odds of an ordinary storm becoming a damaging one. The second honest thing, and this one is going to disappoint people, this rain will not fix the drought. There's a reflex, understandable and completely wrong, that says a dry summer plus a wet week equals balance restored. It doesn't work that way, for the reason we've already covered. Water that arrives faster than the ground can accept, it isn't a deposit into the water table. It's runoff. It goes into rivers, into drains, and out. Forecasters looking at Europe's August have made this explicit, warning that short-lived thunderstorms may fail to reverse the accumulated water deficit across a continent that entered the month with depleted soil moisture and low rivers. You can have a flash flood and a drought in the same field on the same afternoon. That's not a contradiction. It's the standard outcome when hard ground meets fast rain. And the third thing, which is the one I want to handle carefully, you will see Valencia mentioned in the comments under every video about this. On the 29th of October, 2024, a cutoff low stalled over eastern Spain, and the town of Chiva recorded 491 millimeters of rain in 8 hours. A year's rainfall inside a single working day. More than 230 people died, most of them caught in cars or on ground floors, as water rose faster than anyone believed water could rise. That happened. It's the reference point everyone reaches for, but it is a reference point, not a forecast. Nothing in the current data says a comparable event is coming, and anyone telling you otherwise is inventing. What Valencia actually teaches is narrower and more useful than a prophecy. It teaches that the fatal variable in a Mediterranean flood is almost never the total rainfall. It's the interval between the water arriving and the people moving. That interval is where the deaths live, and it's the only part of the whole system that individuals have any control over at all. Which brings me to what any of this means if you're standing in it. If you're in the storm corridor this week, in southern or eastern France, in Aragon or Catalonia, in the Alpine Belt or the plains of Central Europe, the practical list is short and boring, and it works. Bring in the garden furniture and anything else that becomes a projectile in a 100-kilometer-an-hour gust. Park away from trees rather than under them, because falling trees during summer storms in France have killed people in each of the last several seasons. If hail is in the forecast, get the car under cover, since 5-centimeter stones total a windscreen in seconds. Assume power cuts and have a torch that isn't your phone. And if you're anywhere downhill of ground that burned this summer, in the Gironde, in the Landes, in the Var, west of Madrid, in Avila or Toledo or Guadalajara, that list gets one more item, and it's the most important one on it. Do not judge the danger by how hard it's raining where you're standing. On a burn scar, the rain that gets you fell somewhere you can't see minutes ago, upslope. The water arrives without a warning shower in front of it. If a storm sits over burned high ground above you, move away from the channel that drains it before you have a reason to. Ordinary judgment about rain is calibrated for ordinary ground, and burned ground isn't ordinary for years. The picture for the rest of this month, as the modeling stands, is not a return to relentless heat, and it's not a clean break either. It's a collision zone. Central Europe sits on the boundary where the hot air and the Atlantic fronts keep meeting, and each meeting has the same shape as this one: build, break, storm, repeat. So here's what to actually watch, and these are specific. Watch the vigilance maps, not the temperature forecasts, the warning maps from Météo-France and from AEMET, because those are the fastest updating honest signal available to anyone. In Spain, watch whether the instability that forecasters expect to build from around August the 10th organizes in the northeast, and whether it does so as scattered storms or as a cutoff low, because that single distinction is the difference between a loud afternoon and a bad one. Watch the Ebro. Watch whether the storms in Aragon and Catalonia land on catchments that burned this summer, because that's where the multi-hazard research says the numbers stop behaving normally. And watch the sea temperatures, because the Mediterranean is the account this whole autumn will be drawing on. The heat that's sea absorbed through June and July doesn't disappear when the air cools. It gets released slowly into every system that crosses it between now and November. September and October are when the Mediterranean historically cashes out, and it enters that season warmer than almost any year on record. The Gironde fire was declared fixed on the 1st of August. 2 hot spots were still burning on the Cap Ferret Peninsula and in the dune belt south of Lacanau. 208,000 people were cleared to go home. And rain fell that same evening on the Gros Bessalon fire in the Var, which had restarted the day before. That's the shape of it. The rain came, and it came at the wrong time, in the wrong form, onto the wrong ground. Subscribe and turn the bell on. When the 10th of August window opens over northeastern Spain, and when the next front lines up over that burn scar country, we'll break down exactly what the models are showing and exactly what they aren't. This one isn't finished.